Okay, so now the next case, it is using the PSO particle swarm theorem. It is the same of the GWO. The only difference it is the optimization methods. So we will go through the files quickly. But we will explain in the detail the PSO code. As you mentioned before, like this, it is the OP case. It is the mini program from here to call the optimization program, and we initialized, as we mentioned before, the optimization variables, and also the getted the result. After getting the result, we printed in the screen the result, the power loss, the reactive power loss, the voltage deviation, voltage stability index, and total system cost. And then we printed the convergence curve, voltage profile, and also the system profiles and the load profiles. Um, and then also the load data and the line data, the same thing, and also the profile of the real power, reactive power, PV, distributed generated 1 and 2, and EV, and distributed generation cost. This is the common program, and the same thing also of the cost function, the load flow function, initial parameters, and the reconfiguration process here, as you see here, and then preparing data and starting to the load flow program. And after we finished the load flow program, we calculated the losses, we calculated the minimum maximum voltage, and also we calculated the total system cost and voltage stability index, as you see here, and then put it in the fitness value as the object function, and get it as an output from this cost function. This is all the common file with the GWO process, but the only difference, it is the optimization process, as you see here. The same GWO, we call it from the main program, and we have input the number of population and the maximum iteration cost function, and then the number of variables, and this is the initial parameters for the PSO: inertia weight, maximum inertia weight, and minimum inertia weight, and then some numbers, variables, some numbers, and the velocity and vectors and position vectors initialized, and the best position score, and the best position score, and the best position, and the global best score, and the global best position. And the last one, it is to initialize the convergence vectors. And after that, as you see here, we go to the initialization process to randomly selected which the line it is open it. And after we selected that, now we sorted that program to see which one it is, which the line it is the more has more variables or more values. And then after we sorted that, we determined which the line it is open it, depending on the sort of the position. And then we applied this line that we will open it in the cost function to calculate the fitness value. And after that, we updated the best score, best position, best score compare with the fitness values, and store it the best position, best score, and the position best values. And also we compared the global best. What is the difference between the best, the position best score, and the global best? The position best score, that mean in each particles has the best value that we reach it for each particles, but the global best, it is the best one, which is the best position that get it the best fitness value or the minimum fitness value. this value for each position. The global best, it is for whole, which one it is the best from the whole, which one it is the best. And after that we updated the weight of the PSO and updated the velocity and the position of the particles depending on the equation of the particle swarm theorems or optimization. This is the equation of the updated the velocity, and after we updated the velocity, now we updated the new position depending on the new velocities, and after we updated that we sort the position, and then we selected which the line it is or has the biggest values, and put it as the openet depending on the line values. And then we applied the new openet line or the new configuration of the network on the cost functions or the load flow function to calculate the fitness position, the PSO, fitness PSO, and compare it with the current fitness value that we get it. And then we printed or store the G best score in the convergence curve, and display the convergence in the screen command window, and then repeated the process for the maximum iteration. We will go through back to the quickly for the maximum for the process of the PSO position. As you see here, we apply it. We now, after we get it the new position, now we arrange which the position has, or which the line has more values, and after that we selected the first five. The first five that has the more variables than other, and this is the five. It is open it from each line, and after that we applied the cost value in the position, and selected the best the particle best score and the global best score depending on the fitness value that we get it from the applied the on the cost function. And after that we updated the W of the PSO, updated velocity and position particles, and then after we updated the position of the particle, now we sort dependent on the value of each line, descending sort, and after that we selected the first biggest, or the first five position that has the more variable than other, and open it that line and apply it on the cost function, and calculated the fitness PSO in the new fitness PSO and compare it with the old one, and then we printed the G best score and printed the convergence value on the command, and repeated this process for the maximum iteration. And then after we finished the process of the PSO, now go back to the main program to printed the global best position that we get it and how much, and apply it on the load flow. As you see here, we apply it the best position in the load flow to get the output from the load flow, and then to print the result as we explained before in the GW program case. That's all for the PSO. The only difference it is the optimization file. We hope it is clear. If you have any question, we can ask us what do you think, or what the idea or the line it is not clear for you. Thank you very much.